If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in intermediate level on ellipse. So today we will see the number of tangents that we can draw to an ellipse from a given point. Okay, then let's see this. Okay, the article is now number of tangents that can be drawn from a ellipse from a given point. The earlier one was number of tangents you can draw with a given slope. Suppose a particular slope is given, then how many tangents will be there? In case of parabola, it was only one. So here they are asking number of tangents that can be drawn to an ellipse from a given point. Suppose you have a ellipse, suppose a point is given, how many tangents you can draw? If it is on the line, then only one. If it is inside, then no tangents. So that conditions. So from the graph you can see, if it is outside there are two tangents, if it is on one, if it is inside, then no tangents. So same conclusion we will draw in mathematically also. So your given point, given circle is this one, and your point is this one. One point is given x1, y1. You don't know where the point is. It can be inside, on, or outside. The tangent to the ellipse, any tangent to this given ellipse, we have just now derived this condition. So if you want to write any tangents to this ellipse, you will write it in this format. Okay. Because these tangents we are drawing from the point. Suppose the point is outside for sake. Because you are drawing tangents from this point. So this because the tangents that you have written in equation 1, that you have drawn from the point x1, y1. That is the idea, na? From x1, y1 you will draw tangent. So that means x1, y1, this line should pass through x1, y1, because from that point you are drawing the tangent. So this is the equation of the tangent. So if you put that point, it should satisfy. So if you put a y1 x equal to x1, it should be equal to. If you take square, it will be something of this one. So this is a quadratic of m, you can see. So you will get 2m, m1, m2, two slopes. So from a particular point, that means in general, we can say we can draw two tangents. Now tangents can be real, tangents can be imaginary depending upon the value of the m. If m is real, then it is real tangent. If m is imaginary, then imaginary tangent. If m is equal root, repeating root, then only one tangent you can draw. So that depends on the case of the discriminant. What is the discriminant of this equation? So b square minus 4ac. b square minus 4ac if you do a little bit, open it, then you take a square, so this will look like something like this. Now if this is greater than 0, equal to or less than, depending on then your discriminant will be greater than, equal to or less than. So if it is equal to this, greater than 0 means this greater than 0. This greater than 0 means p is outside. Equal to means on, less than means inside. That's one we have seen from the article point with respect to the previous article. So p is outside. If p is outside, then this is greater than 0. That means d is greater than 0. That means two real root, m1, m2. That means you can draw two tangents. If p is on the ellipse, then you have equal to 0. That means d equal to 0. That means only one real root, m1, m1, repeating root. So you have only one tangent. If p is inside, then d is less than 0. Then both the roots are imaginary. That means you don't have any real tangents. If at all there are tangents, there are imaginary tangents. If you like the video, then press the like button and please give your valuable comments in the comment section.